Hello and welcome to the sequel to the most popular video of the channel, which is the 50 insane QA shortcuts. Now I have a compilation of 15 new questions and 15 new shortcuts that you would have never seen before. So make sure that you go through each and every question first and then have a look at the shortcut that I'm going to disclose. Also, the link to the first 50 insane QA shortcuts video is there in the description box below and in the pinned comment. So do check out that video as well to get your minds blown away. Let's start with the first question. So try this out on your own and then have a look at the shortcut that I'm going to share. Now, if you look at this particular question, if you look at what is happening, he is buying 110 centimeters using a faulty meter tape, which basically means he is giving money which is for 100 centimeters, but he's buying something which is worth 110 centimeters. So if you do it mathematically, the shortcut comes a bit later, so stay tuned for that. But mathematically, if you are looking at this, he's basically getting a value of 110 on an investment of 100. What happens in the second step? He's actually selling 90 centimeters, but he's getting 100 rupees. So his return on investment is 100 on an investment of 90. What exactly is happening next? He's getting a discount of 5% on the marked price, which essentially means he's getting 100 rupees worth of stuff by paying 95 rupees. That is the actual, you can't say profit percentage, but that is basically the multiplier that we are going to get. And finally, he's selling it at a discount of 10%, which basically means he's going to get 90 by 100 of the value. Now, if you look at these numbers that we have, we can happily cancel out all the 90s and all the 100s. Now, this we can cancel out. We'll get a 19 and this we will get a 22. So it basically means he's investing 19 rupees and he's getting 22 rupees in return, which basically means a profit of 3 out of 19, which will be 19 ones are 19, we will be left with an 11, 19 fives are 95, and the rest doesn't matter because it is going to be a profit of 15 odd percent, which is option A. So that should be our answer. But is there an easier way of looking at it? Absolutely yes. You can approximate the values and see what is happening here. 110 centimeters is 10% greater than a meter. So you can say that he is benefiting by approximately 10%. In the second case, he is measuring 90 centimeters against 100 centimeters. So you can again say that approximately he is benefiting by 10%. But he's also getting a discount of 5%. So he's again getting benefited by 5%. And he's giving a discount of 10%, which means that he will be losing 10%. Now these two get cancelled out and we can say that the effective percentage change is going to be very close to 15%. And that is our answer, which is option A. And we can use this method purely because the options are far apart. Let's look at the next question now. Now Bhuvan, Gauri and Elizabeth completed a job in 10 days in the following manner. So everything has been given to you. Now you have to figure out who is the fastest worker and how much time would that fastest worker would have taken to finish the job working alone. Now you don't need complicated equations, you don't need complicated fractions here. You just have to pay attention to what is happening. So they finished the job in 10 days. So what happened in the first 3 days? Bhuvan, Gauri and Elizabeth worked together and completed 37% of the work, and this happened in 3 days. But effectively they have completed the work in 10 days, which means that Gauri and Elizabeth after Bhuvan's departure would have worked for 7 days together and would have finished 63% of the work. So can we say that Gauri plus Elizabeth will do 63% in 7 days, which basically means they will do 9% per day. That is what we know. We also know that the work done by Gauri in 4 days is equal to the work done by Elizabeth in 5 days, which basically means that Gauri is more efficient, right? So for every 5 units of work done by Gauri, 4 units of work will be done by Elizabeth. So if 9% of work is done in a day, can we say that Gauri would do 5% of the work every day and Elizabeth would do 4% every day? So we can definitely say that Gauri is the faster between the two. But what about Bhuvan? We can see that they did 37% in 3 days, out of which 9 into 3, that is 27%, would have been done by Gauri and Elizabeth, which basically means Bhuvan did 10% in 3 days or Bhuvan did 3.33% of the work every day. So Bhuvan is even worse than Gauri or Elizabeth. So we know that Gauri is the fastest worker. Gauri does 5% of the work every day. Now if she does 5% of the work in 1 day, how many days will she take to complete 100% of the work? The answer is very straightforward. It is going to be 20 days. So the correct answer here is 20. Let's look at the next question. Now have a look at this, think about it for a bit and then have a look at the solution that will follow. Now, if you look at the question, you might be tempted to use the recursive logic approach, wherein you start from the end and then keep on increasing your numbers. But the problem here is that we don't know how many times do we have to increase those numbers. So that is going to be an issue, and that is why we may or may not be able to use this logic. Also, if you look at it, the first player is receiving 50 toffees and then 1/10. The second player received 100 toffees. So now again there is a discord. So we don't know what the last player is going to get. So recursive logic will not work here. On the other hand, if you look at it, everybody has got the same number of toffees. So even if you find out two people who would have got some toffees, we will know that that number is going to be equal in both the cases. So let's look at what is happening in the first case. So let's say, for example, Mr. Gill has n toffees with him. Now what is happening is he is giving 50 toffees first of all, and then whatever is remaining, he is giving 1/10 of that. So 1/10 of n minus 50. This has been given to the first player. What about the second player? The second player will get 100 toffees for sure, and he will get 1/10 of the remaining toffees. Now how many toffees remain? N minus the 50 toffees given to player 1 minus 1/10 of n minus 50, which were again given to player 1, and then again these 100 toffees that would have been there. So all these toffees remain now. So out of the original toffees, 50 and 1/10 of n minus 50 were given to player 1 and 100 more were given to player 2. So this is basically what remains. Now I will strongly suggest that you don't expand this entirely at this step, you keep it for the next step. Now we can see that 50 and 100 will get adjusted and it will become 50 on the right hand side. I can see 1 by 10 into n minus 50 on the left hand side. I can also see that 1 by 10 into n minus 50 is also visible on the right hand side. So this is also accommodated. Minus 1 by 100 into n minus 50, this is going to be this part, and minus 100 into 10 is going to be minus 10. So what am I going to see? I'm going to see that these two parts get cancelled out. So now I have only one term in n. So what will I get? N minus 50 by 100, I'll just write it here. N minus 50 divided by 100 is going to be equal to what? 50 minus 10, that is 40. So n minus 50 by 100 will be equal to 40. That tells me that n will be equal to 4000 plus 50, that is 4050. So Mr. Gill had 4050 toffees. We also know how much or how many toffees did the first player get. So 4050 minus 50 is 4000. 4000 divided by 10 is 400. So 450 is what we are going to get. So the first player would have got 4050 divided by 450, that is 9. Or we can say that one player got 450 toffees, so 9 players would be the ones among whom these toffees have been distributed. So your answer should be 9. Absolutely wrong, because Mr. Gill is also the captain of the team and is also there in the team. So in this case, the correct answer is going to be 9 players plus Mr. Gill, that is 10. So this is a supremely complicated trap that exists. You might mark 9 as the answer, but the actual answer is going to be 10 in this particular case. Let's look at the next question now. Now in this question, you have a container, liquid, and some operations that are being performed. So have a look at this and then look at the solution that will follow. Now in this case, if you look at it, we know that n minus 1 operations have been asked. So if I say that I put n equals 1 here, then what will happen? After 0 operations is what I need to figure out, which basically means I need to figure out what exactly was the volume of milk at the start. What was the volume of milk at the start? It was 30 liters. So if I put n equal to 1 in these options, I should get my answer as 30. So 30 upon 3, 10, not my answer. 30n, that is 30, divided by n equals 1. 1 minus 3 plus 2 will make this 0. So this is absolutely not my answer. 60 upon 1 plus 2, or 60 by 3, 20, not my answer. 60 divided by 1 plus 1, 60 divided by 2, 30, that is my answer. So I don't need to do any iterations. I just need to put n equals 1 and I should be fine in this particular context. You need not even put n equal to 2. Just have to put n equal to 1 and you should be done. Let's move on to the next question now. So if you look at this question, again, there is a very elegant way to solve this. So try this out and then have a look at the solution that will follow. The cost of building a wall is 1347 rupees, some awkward value. What would be the approximate cost? Again, a very big red flag. Approximate cost. I will run away from these questions, but I will not run away from this question. Of building the wall, if the wages of workers per day increases by 12.5%, so I know that the entire cost is going to increase by 12.5%, and the working hours increases by a fraction of 1 by 20, which is 5%. Now, if the working hours per day increases, then what happens? Who benefits more? Does the employer benefits or the employee benefits? The employer benefits, right? Because you are working harder every day. So the work will be done in fewer days. So what is happening here? The cost increases by 12.5%, but it also reduces by 5%. So what can I say is the approximate benefit that is happening, or the approximate increase in the cost that is happening? Can we say that it will be approximately 7.5% or approximately 7-ish% is what we can see. Now the initial cost is 1347. We have understood that the effective cost is going to be more than 1347. So this is not my answer. This is not my answer. By what quantum does it increase? That is what I'm looking at. So 1443 and 1592. Now think about this. 1347, if you look at 10% of this, it's going to be around 134. 1347 plus 134 will be what? It will be 1481-ish. That will be the number that we will have. But this increase is by less than 10%. So what will happen? Our answer is going to be less than 1481 or 1443. 1592 is way higher, and that cannot be our answer. So the actual answer is 1443. You can do it using the conventional method as well, but this is basically the shortcut that you can use to solve these kind of questions. Let's move on to the next question now. Now we have Ajay, Vijay and Dhananjay. They purchased 1, 10 and 25 notebooks and so on and so forth. So do have a look at it, try it out, and then have a look at the elegant solution that's going to follow. So in this case, if you look at it, we have to look at the unit price. So Ajay, Vijay and Dhananjay. Now Ajay bought one notebook for 14 rupees. So the selling price to Ajay was 14 rupees. What about Vijay? 130 rupees for 10 notebooks. So 13 rupees per notebook. And what about Dhananjay? 300 divided by 25. So you are going to get 12 rupees per notebook. Now, of course, because you buy more, you are getting a discounted price. Makes sense. But we also know that in terms of Ajay and Dhananjay, right, the shopkeeper made a profit of P% here and Q% here, such that P equals twice Q. Now it is very obvious that this is 14, this is 12. If I take 10 as the base in both the cases, I will see that this is 20% and this is 40%. That is what I will be able to see. Now, of course, in this case, if you look at this as 10 and this as 13, he would have made a profit of 30%. And that will obviously be the answer. So the profit that the shopkeeper made in his transaction with Vijay is going to be 30%. So option D is the correct answer. You don't need to solve for anything else. Just need to look at P, Q and logic. 10 becomes 12, 10 becomes 14, 20%, 40%. It fits P equals to Q. That should be our answer. Now let's look at this one. Again, try this out on your own and then have a look at the solution. Now we have to find the sum of the first 5001 terms of the sequence. 1, 7, 1, 1, 7, 7, 1, 1, 1, 7, 7, 7. So you will realize 1, 1, 1, 7. 2 1s, 2 7s. 3 1s, 3 7s and so on. You have to find the sum of the first 5001 terms. Now what do you observe here? Every term is odd in nature. And if we add odd numbers an odd number of times, you are going to get an odd number as the answer. So I can say that option B and option D are definitely not my answers. So I am left with option A and option C. What do you think is the obvious answer? 5001 terms. Every term is either 1 or 7. So my answer has to be greater than 5001. So my answer is option C, that is 19911. That's it. You don't need to calculate it entirely. And given that that is the point of the video, I will not show you the actual solution. If you have a solution, you can put it in the comment section below. But this is basically how you can solve this particular question type. So always remember that sum of odd numbers is going to be odd. Let's look at the next one now. Now in this case, x plus y plus z equals 1, x, y, z are non-negative numbers. What can be the minimum possible value of the expression? Now there are two things that I will strongly suggest that you do in these cases. One is you put x equals y equals z equals some number, or you put x equals y equals 0 and whatever is the remaining part, that will be z. Try out these two things, you will get your answer in most of the cases. So in this case, x plus y plus z equals 1, x, y, z are non-negative numbers. So x equals y equals z equals 1 by 3 is one case, and x equals y equals 0 and z equals 1 is another case. Let's look at both the cases. So what is happening here is, because there is a proper cyclicity that we can see here, yz and minus x is in one term, xz and minus y is in another term, xy and minus z are in a third term. So we know that if we replace x by y, y by z, x by z, the effective outcome is still going to be the same. So what we know is, because of this beautiful cyclicity, we can say that if everything is equal to 1 by 3, my answer is going to be 3 into one of the terms. Now it is raised to minus 1, which basically means 1 divided by this term, which will be 1 divided by 2 minus 1 by 3 plus 1 by 3 into 1 by 3, that is 1 by 9. So what am I going to get in this context? I'll get 3 multiplied by 9 because 9 will come to the numerator. What about the denominator? This 2 has to be written in the form of something by 9. So I'm going to get 18 minus 1 by 3 will be what by 9? It will be 3 by 9. So 18 minus 3 plus 1. So my answer is going to be 27 divided by 18 minus 3, that is 15 plus 1, that is 16 for this case. So I am getting 27 by 16. I can see this in the option as well, but I'll also check this one and see what happens. So in this case, x equals y equals 0. So in this case, if you look at x equals y equals 0, these two terms will definitely become 0 and my remainder of this will be 1 by 2. In this case, x equals y equals 0, again it is a problem. So again my remainder will be 1 by 2. And in this case, because x equals y equals 0, this term will be 0, but 2 minus 1 will be 1 raised to 1, so I'll get 1. So I'm going to get my answer as 2. Now which is the minimum of these two values? 2 and 27 by 16. I know that 27 by 16 is less than 2 because 32 by 16 would have been equal to 2. So 27 by 16 is less than 2. That is our answer. Just mark it and move on in life. Let's go to the next question now. So if you look at this question, very interesting question. X and y are natural numbers such that they satisfy the equation. You have to find the maximum possible integral power of 6 in xy factorial, x into y. So that basically tells me that I have to maximize the product xy. Now if I want to maximize the product of two numbers whose sum I know, how will I be able to maximize them? If one number is as low as is possible, one number is as high as is possible. So in this particular context, if you look at what exactly is happening in terms of this, you have to understand that x into y, if I want to maximize, I will have to make one thing 1 and I will have to see what happens to the other thing, because that might be the way in which you might be able to solve this. So there is a traditional way of doing it, but just put x equal to 1 and see what happens. If you put x equal to 1, you are going to get 1 plus y plus 31 equals 2 into 1 into y. Or in other words, you are going to get y equals 32 because 2y minus y will be y, 31 plus 1 is 32. So y equals 32, x equals 1 is what you are going to get. Now in this context, if y is equal to 32, 32 factorial or y equals 32, so y into x will be 32. So 32 factorial, what is the largest power of 6 in 32 factorial? Now we know that 6 comprises of 2's and 3's are less frequently occurring in a factorial compared to 2's. So I'll just use the basic method. 32 factorial will have how many multiples of 3? So 32 by 3, that basically means 10. Right? So we will have 10 multiples of 3 that are there. We will also have 10 divided by 3 or 3 multiples of 9 that will be there and 1 multiple of 27. So the answer in this case is 14. You can also look at what happens if x equals y. Try that out and let me know in the comment section what do you think will be the answer if x equals y in this particular case. Now let's look at the next question that we have here. And this is a very interesting question again. So you have to find the sum of this infinite series. 5 upon 1 square into 2 square, 11 upon 2 square into 3 square, and so on and so forth. Now what you are expected to do in this case is, of course, you are supposed to find out what exactly is the sequence that we have here, right? And that is typically going to be an issue because I don't know how many of you will be able to figure out that this sequence is basically 1 plus 2 plus 1 into 2 divided by 1 square plus or 1 square into 2 square. The second term is 2 plus 3 plus 2 into 3 divided by 2 square into 3 square. The third term is 3 plus 4 plus 3 into 4. Yeah, 3 into 4 divided by 3 square into 4 square. Now this is a very difficult thing to figure out. And even if you figure it out, you have another lot of steps that you will have to do. So what do you do here? You use the calculator. Very simple. So in this context, you are going to get 5 divided by 1 square into 2 square, that is 5, that is 1 into 4, that is 5 by 4. The second term will be 11 divided by 6 square, that is 36. The third term is going to be 19 divided by 12 square, that is 144. The fourth term is going to be 29 divided by 20 square, that is 400. You will see that the denominator is increasing much faster than the numerator. Now what do you do in this case? You basically look at the terms that we have. 5 by 4, you can use the calculator, but you will get 1.25-ish. 11 by 36, approximately 1/3. So 0.3 is what I'm looking at. 19 divided by 144 is going to be more than 10%, but of course less than 20%, right? So 14.4 will go away. You'll be left with the 4.6. So you can say 0.12 kind of a thing. And 29 by 400, if you look at it, this becomes very small, 0.07-ish is something that you will get. This basically adds up to 567 plus 7, 14 to 3, 4, 5, 6, 7 as it is 1.74. And now it is going to diminish even further. So it does not have the legs now to go way beyond 1.74. Now if you look at this option, we are already beyond 3 by 2. 7 by 4 is 1.75, but we are too close to 1.75. And if you do it properly using the calculator, you will see that we are beyond 1.75 as well. So we are not looking at this as the answer. 5 by 2, again, if you look at it, 2.5 is way farther than we were supposed to be. So in this particular context, the correct answer is option C, that is 2. If you just take the sum of the first few terms, you will be able to get the answer very quickly using the on-screen calculator. Let's move on to the next question now. Now we have to find the minimum value of this function that we have, and it looks a very complicated function at first, but you have to understand what is happening here. So just look at the coefficient of x square, because every term has an x square here. So this is x square plus x square minus x square minus x square. So all x squares have gotten cancelled out, plus x square plus x square. So basically I am going to get something in 2x square. Now what does that tell me? That this function is a quadratic function. That is what it tells me. And we know that in a quadratic function where the coefficient of x square is positive, you will always have a curve that looks like this. And this is going to be symmetrical around this point, which will also be the minima. And where does this happen? This happens exactly in the middle of the curve. So whatever are the roots, they have the curve has to basically be in such a manner that it will have the midpoint here where the minima will occur. Now we have to figure out where will the midpoint be. So in this case, if you look at these, the individual roots that we have here, we can just map those roots and see what happens. I have 5, 7, 4. So 4, 5, 7, 8, 3 and 9. So I can say 3, 4, 5, 7, 8 and 9. So typically these are the critical points that are there. We can also see that these are all symmetrical around this midpoint. So my minima has to happen at 6. What is the value of the minimum or what is the minimum value of the function? So what will you get here? 6 minus 5 the whole square, that is 1, plus 6 minus 7, 1 square, that is 1, minus 6 minus 4, that is 2 square is 4, 6 minus 8, again 2 square is 4, plus 6 minus 3, that is 3 square will be 9, and 6 minus 9 minus 3 square will again be 9. So you are going to get a total of 1 plus 1, that is 2, 2 plus 18, that is 20, 20 minus 8, which will be equal to 12. So the correct answer is 12. You need not expand the entire thing. You need not use derivatives here. You need not use completing the squares or anything. You can just observe and see that everything is symmetrical around 6. So 6 has to be the midpoint around which this entire thing will be based. Now let's look at the next question. So try this out and then have a look at the solution. What is the remainder when n factorial plus n factorial minus 1 and so on and so forth till the time you reach this number n factorial minus 2006. So you can see that all the even numbers have a minus sign and all the odd numbers have a plus sign when it comes to the number. You have to look at divided by 1003. Now the first question is why 1003? What is special about 1003? Nothing. So 1003 is basically a proxy for a very large number. Your question could have been 2007 as well. It could have been 2025 as well. But 1003 is a proxy for a very large number. So what do you do in that case? You look at a much smaller number. Why 1003 or what is the significance? Because this is an even number and this is an odd number. Now we are looking at something which is an odd number. So what I will suggest in this particular case is this number divided by 2 should give me a significant odd number. So what will I do in this case? I want to find the remainder. So I can't divide by 1 because the remainder when I divide by 1 is always going to be 0. So I will look at the next best thing, which is 3. So let's say for example, I am saying that instead of 1003, I am taking n equals 3. So what am I going to do? I am going to go on till 6. So I'll get 3 factorial plus 3 factorial plus 1 plus 3 factorial minus 2 plus 3 factorial plus 3 plus 3 factorial minus 4 plus 3 factorial plus 5 plus 3 factorial minus 6. Now you need not divide this entire thing by 3 because you know that all 3 factorials are definitely going to be divisible by 3. So that leaves me with 1 minus 2 plus 3 minus 4 plus 5 minus 6. Now this sing-song way of talking about this will tell you that we are going to look at a minus 1 here, we are going to look at a minus 1 here, and we are going to look at a minus 1 here. So there are 3 pairs of minus 1 or minus 3, which is again divisible by 3. So the first part and the last part are both going to be divisible by 3, which tells us that the answer has to be 0. Same thing will work for 1003 as well. If n factorial is 1003, I will get these successive terms to all add up to minus 1 1003 times. So the first term is a multiple of 1003, the second term is a multiple of 1003. So if you divide it by 1003, the answer of course has to be equal to 0. So you need not even divide it, actually you will just have to figure it out and you will be able to answer the question. Now let's look at this one. Very, very interesting question. A and B are integers. How many ordered pairs, which basically means A comma B and B comma A are two different ways of answering. So if you get your answer as let's say 5 comma 6 or 5 and 6 can be a pair, you will have to say 5 comma 6 and 6 comma 5. These are the ordered pairs that are there. So we have to find the pairs that satisfy this particular equation. Now how do you go about this? One way of looking at it is by substituting values and trying to see what happens. The other thing that you can do in this context is you can just take a constant, or in this a common rather, you will get a into a plus b square equals 1. But instead of a, you could have also taken b common. So if I would have taken b common, I would have got b into a plus b, right? B into a plus b, if I take common from here, plus a square equals 1. Now what I can do here is I can just add these two terms. And then what am I going to get? I am going to get a plus b into a plus b, or a plus b the whole square plus a square plus b square equals 2. This is what I am going to get. Now when does this happen? When does this basically happen? Because we have 3 squares that are there, a and b are integers that are there. How do I get the sum of the 3 squares to be equal to 2? Right? I will have to either ensure that this part is 0, this part is 1, this part is 1. That is what I will have to look at. Or I will have to ensure that this part is 1, this part is 0, this part is 1. Or I will have to ensure that this part is 1, this part is 1 and this part is 0. Because everything is an integer. So it has to be a combination of 1 square, because as soon as 2 square comes into the picture, you will not have anything that will offset the extra 2 that we are going to get. So these 3 cases exist. Now a plus b equals 0, a equals 1 or a square equals 1, b square equals 1 will basically have 2 solutions. What are these 2 solutions? Either a is 1, b is minus 1, or a is minus 1 and b is 1. This one will have how many solutions? You will have guessed by now. A square is 0, so a definitely has to be equal to 0, but b square is 1 means that b will be either plus 1 or b will be minus 1. And finally, we know that b square equals 0. So it's the same thing. B will be equal to 0, but a will be plus 1 or a will be minus 1 in this particular context. So if you do this, you will end up getting 6 ordered pairs or 6 solutions that will satisfy the equation. So this is one thing you can do. Instead of just relying on observation, you can add these 2 things and that will make your life slightly easier. Let's move on to the next question now. So this also looks to be slightly complicated from algebra. So let's see. How many ordered sets exist such that a, b, c, d are all integers? And we know that a into b into c equals d. We also know b into c into d equals a. We also know c into d into a equals b. And because of the beauty of cyclicity, we will know that d into b into a is equal to c. Now we have to figure out how many such sets exist. So what will I do in this case? I can simply multiply everything and see what happens. Now a is appearing thrice, b is appearing thrice, c is appearing thrice, d is appearing thrice. So we will get a cubed multiplied by b cubed multiplied by c cubed multiplied by d cubed equals a, b, c and d. Now one obvious solution is you can cancel out a, b, c, d from both sides, but you will be able to cancel it out only if they are not equal to 0. But what if a, b, c, d are equal to 0? Now one of them cannot be equal to 0 standalone, because if d is equal to 0, let's say a multiplied by b multiplied by c equals d means that one of them has to be equal to 0. Also the other one has to be equal to 0, other one has to be equal to 0, other one has to be equal to 0. So the first solution that you will have is all zeros. The next solution you can think about is 1, 1, 1 and 1. Because a, b, c, d, if all of them are 1, then you will of course get the answer as 1 itself. What about another solution? Now if you look at another solution which is minus 1, minus 1, minus 1, minus 1, that will also satisfy. So a lot of people reach here and then they give up. But in this context, you have to understand another thing. You also have to understand that ABCD whole cube will be equal to ABCD, which basically means that if you are looking at ones here, you also have to understand that you can have two minus ones and two plus ones. And the product in this case is going to be 1 cubed, and the product in this case is going to be equal to 1. So this is also a possibility. Now which two among these four can be ones? I'll be able to do that in 4C2 ways. But the problem is I can have only 3 combinations, right? So I'll not be able to say 4C2 directly without even thinking about it. So what are we looking at in this context? 4C2 meaning that I will select 2 out of 4. So I can either select A and B to be both minus ones. I can select A and C to be both minus ones. I can select A and D to be both minus ones. Then BC, BD, CD. So this holds true. This should be the way in which I am doing this. So there are a total of 3 plus 6. That is 9 outcomes or 9 cases wherein you will have this entire thing getting satisfied. But the crux of the matter is you go from here to here and then you apply a bit of logic. So that is basically the way in which you can look at this particular question. Let's look at the next one. Again, we are talking about modulus and inequalities. So try this, and if your answer is infinite values, then you can say 9999 is going to be your answer. So how many integer values satisfy this? So first of all, if you have looked at our functions class or if you have looked at our algebra marathon, you will be able to make sense of this very quickly. So if you have not looked at the algebra marathon and the arithmetic marathon, please have a look at it. That is the most crucial video that you can go across. Now x minus 2 will basically means that one person will be at 2. X plus 3 means one person will be at minus 3. 5 minus x means that one person will be at 5. And x minus 8 means that one person is at 8. Now the question can be kind of paraphrased in such a manner that we are saying, look, that okay, one person is at minus 3, one person is at 2, one person is at 5, one person is at 8. Where do they meet so as to make sure that their distance covered is less than 16? Let's say everybody meets here at this point. What is going to happen? This person is going to cover 5 units, this person is going to cover 8 units, this person is going to cover 11 units. Together they are covering 24 units, which is way beyond what they are expected to cover. So in this case, the minimum distance that will be covered will be if everybody decides to meet here, here or somewhere in the middle. So let's say everybody decides to meet at 2. So this person will have to cover 5 units. This person will have to cover 3 units. This person will have to cover 6 units. So you can see that cumulatively they are covering 14 units. Now that is an optimum solution. Similarly, if you look at 5, you are going to get the optimum solution. Also, if you look at any point between 2 and 5, you are going to get the same answer. So 2, 3, 4 and 5 are of course the 4 points wherein you will be able to reach within 16 or in 14 units. But what happens if we shift one place to the left? What happens if they decide to meet here at 1? Now this person will have to cover 4 units, 2 will have to cover 1 unit, 5 will have to cover 4 units, 8 will have to cover 7 units. So we are going to get 9 plus 7, that is 16 units, which is not less than 16. So even if we shift it by 1, what is happening here is what you have to visualize. So earlier 2 was not traveling, right? And 5 were traveling to the left, 8 was traveling to its left, minus 3 was traveling to its right. Fair enough. But now what is happening? 2 has to travel 1 extra. 5 has to travel 1 extra, 8 has to travel 1 extra. So 3 extra are being traveled. And whose effort is saved? Minus 3's effort is saved by 1, which means that I still have 2 extra, which will take it from 14 to 16. So in this context, 14 is the minimum value that can happen, and that is the only value that will be less than 16. So in this context, the correct answer will be 2, 3, 4, 5. So there are 4 integer values that will satisfy this particular inequality, and that's why the correct answer here is going to be 4. Let's look at the next question now. At how many points does the graph y equals mod of x minus 5 minus 14 kind of touch the x-axis? That is what has been asked here. Now one way of doing this is by plugging in values and doing it. What happens in this case? Let's say we know that okay, this will touch the x-axis, which means y will be equal to 0. So I can say that mod of x minus 5 minus 14 will be equal to 6, which basically means that this part will either be equal to 20 or it will be equal to 8, because this can be either plus 6 or minus 6. So then you will see that okay, if this is 20, then x minus 5 should be equal to plus 20 or minus 20, which will give me two values. So if x minus y equals plus 20, I'll get a 25. If it is equal to minus 20, I'll get a minus 15 here. What if x minus 5 is equal to plus 8? I'll get x equals 13. X minus 5 equals minus 8, I'll get a minus 3. And in this context, we'll be able to get the solution, which is 4. But there is another way to look at this. And that is not a very simple way, but again, something that you can use for other graph-based questions as well. So in this case, if you are looking at it again, let's say we are looking at this particular line that existed earlier, which is y equal to x. Now y equal to x, of course, is going to be a line that is going to be something like this. But I want x minus 5, which basically means I have to bring this down by 5. So I will basically draw this line here. Right? Now this is x minus 5. But I want mod of x minus 5. So there will be nothing below the x-axis. It will essentially be something like this. So at this point, which is 5, 0, we will have this line which is equal to mod of x minus 5. Now what I will do is I will use a different colored pen so that you know what is happening next. But we also have to look at minus 14. So it will go 14 positions below, and now my line will look something like this. So this is mod of x minus 5 minus 14. But I want modulus of that. So what will happen in this case? This point that is there, it will be reflected. And my line that I want will be looking something like this. But I don't even want this. I want minus 6. So I will again pull this line down. And if I look at another color now, I will have this as my final line. So it will look something like this. It might not exactly be the way it looks like, but you will know that it will intersect at 1, 2, 3 and 4 points. So visualizing it also enables you to answer this question in the right manner. So if you know that, okay, mod of x minus 5, which basically means it will cut the axis at 2 points, you are taking another modulus, so 4 points. So that is what we are looking at in this particular context. If you can visualize that, you will be able to answer this question even quickly. Let's look at the next question now. Now in this context, we have a function and we want to find the minimum value of this particular function. So try this out and then have a look at the solution. Now I can see that 2x square is present in the numerator and the denominator. So what will I do? I will try to convert this into 2x square plus 1 minus 6. And I'll divide it by 2x square plus 1. Now this, if I split into two parts, this part and the other part, I will get 1 minus 6 upon 2x square plus 1. But I also know that if I want to find the minimum value of this part has to be maximized. And this part will be maximized when the denominator is minimized. When is the denominator minimized? I have something which is absolutely a positive or a non-negative value, which is 2x square. It can never be negative, plus 1. So how do I minimize this? I reduce this as much as I can. So I'll put x equals 0 in this case. So that's why my denominator will become 1. And my answer will become 1 minus 6, that is minus 5. So the correct answer is option D, that is minus 5 in this particular case. So hope you are able to get this one very easily. Let's look at the next question. The next question expects you to find the sum of the infinite number of terms in the series. And whenever you see infinite number of terms in the series, you know what my shortcut is going to be by now. It is simply going to be looking at the values, putting it in the calculator, getting your answer and finish the job. So in this particular context, 3 by 4 factorial. This is going to be 3 by 24, or you can say 1 by 8 plus 4 by 5 factorial, which is 4 by 120, or you can say 1 by 30 plus 5 by 6 factorial or 5 by 720, which is going to be 1 by 144 plus 6 by 7 factorial or 6 by 5040. Now this might be slightly difficult to comprehend, so I'll just write it as 6 by 5040. That's it. You can see that the numerator is not increasing by much, but the denominator is exponentially increasing. It is becoming growing by into 8, into 9, into 10. That is how it will go. So 1 by 8 is going to be 0.125. 1 by 30 is going to be 1 out of 30, right? So it will be very less. It will be 0.03-ish. Or 0.033, let's say, plus 1 by 144, it's going to be even less than this. So basically it's going to be this divided by a large number, right? Divided by 5 approximately. So this will be 0.0066 something and will keep on reducing. So what is happening here? 0.125 is the dominant number that I have here, plus 0.033, which basically means that I will have some 0.158 plus 0.006 plus, which will be 0.164ish. Now we can see that the rest of the numbers will not contribute to a lot. 1 by 3 is 0.33, which is way ahead of where we are. 1 by 6 is 0.1666, which is very close to where we are. 1 by 4 is 0.25, which is very far away. 1 by 5 is 0.2, which is very far away. So the answer in this case is option B, that is 1 by 6. So fairly straightforward question. If you just take values, you will be able to answer it very nicely. Now I'll show you a question that looks very complicated, but in fact is very easy. So how many different terms does this product have? Now, if you start thinking about all the individual terms, you will end up in big trouble. In fact, that might be a good way to solve it if you are very bad at quant. But if you are decently good at quant, you have to understand that there are certain overlaps that are existing here, right? And you will see that C plus D plus E plus F is a term that is present in both the cases, right? So what I can say in this particular context is, if I start expanding this, what will I get? I can say in this context that A plus B, right? A plus B is what we have in this case. We also have C plus D plus E plus F. So that is what we have in this case. So I can say A plus B plus C plus D plus E plus F. That is what we have here, let's say. And in the other bracket, right, what are we going to have in this context? C plus D plus E plus F plus G. Now, how do I improve upon this, or I make my effort less than whatever I'm doing right now? Right? I will just have to take C plus D plus E plus F common and see what all things are we multiplying it by. In other words, what you can do is you can just say, I'll just show it to you in an easier manner, A into C plus D plus E plus F plus A into G. Now this is basically going to be the expansion of this part. Then again, I'm going to get plus B into C plus D plus E plus F plus B into G. So this is how things are going to progress. Now we just have to understand that C plus D plus E plus F into C plus D plus E plus F is going to be a problem, right? That is going to be the only issue that exists. So what will we do? We will ignore that C plus D plus E plus F at this point in time, and we will look at the other terms that are there. Now we can see that C plus D plus E plus F is getting multiplied by everything else as well, right? So in this context, if you just expand this, you are going to see B into C plus D plus E plus F plus BG, C into C plus D plus E plus F plus CG, D into C plus D plus E plus F, all these terms you are going to get. So you are going to see A plus B plus C plus D plus E plus F multiplied by C plus D plus E plus F, right? And then you will have AG, BG, CG and so on, right? So you will have 7 terms that will be present here. Now again, if you are looking at this split, what can we say here? We can see that A plus B is multiplied by C plus D plus E plus F here, and then you have a term which is C plus D plus E plus F square, and this is basically going to be your game changer. So A plus B into C plus D plus E plus F is going to be 4 into 2, that is 8 terms. So we are already accounted for a few terms here. We have accounted for 7 terms, we have accounted for 8 terms. This is basically what remains. Now what is happening in this context is you have C, D, E, F that are present here. You also have to understand in this context that, right, you have to understand one simple thing in this context, which is basically going to be what happens if you are looking at C plus D plus E plus F the whole square. Now you will have one term which will be C square, one term which will be D square, E square, F square. The power has to be 2, which basically means you have to have a combination of C and D, C and E, C and F, D, E, E, F and so on and so forth, right? Now that might make things a bit tricky for you. So in this particular context, you will have to kind of look at it in a simpler manner. So बहुत ज़्यादा इसमें सोचेंगे तो it will not really be productive to you. So make sure that you are looking at the right kind of pairs that are there. And once you figure out the right kind of pairs, that will be much easier for you to solve this particular question. So let's look at the pairs that will enable us to solve this in a much more elegant manner. So in this context, if you are looking at the expansion, I can say that, okay, let's take A plus B here. And in the other bracket, right, let's take C plus D plus E plus F plus G. Now this is a clean sequence that we have here. Now this will contribute to 2 into 5, that is 10 terms. And all will be distinct from each other. We also have C plus D plus E plus F multiplied by C plus D plus E plus F plus G. Now this is the remaining part. But what I can do is I can again split this into 2 parts so that I make my life easier. So I can convert one to C plus D plus E plus F the whole square. The other thing can be G into C plus D plus E plus F. Now this I know is going to be 4 terms. So I am left with this. Now I know that the power of each term has to be 2. So C will have some power, D will have some power, E will have some power, F will have some power, but the cumulative power has to be equal to 2. So in this case, we can use the n plus r minus 1 c r minus 1 formula to find the number of non-negative integral solutions to this equation. So I'll get 2 plus 4, that is 6, minus 1, that is 5, c 4 minus 1, that is 3. So the answer here is going to be 10. So 10 terms of the first expansion, 10 of the middle and 4 of the end. The total number of terms in this context will be 24. You can also figure it out in a simpler manner by just saying that, okay, if there were 6 terms in the first bracket and 5 terms in the second bracket, we should have had a cumulative of 30 terms. But because C, D, E, F and C, D, E, F are giving us a certain number of terms instead of the 16 terms that they would have given. So that is basically the backlog. So they should have given us 16 terms in total if everybody were distinct. But C, D, E, F the whole square is giving us 10 terms, which means that we are falling short by 6 terms. So our answer is going to be 30 minus 6, that is 24. If you can visualize this, great. This is an even quicker method to solve this particular question, but it looks to be a tricky one, but it's fairly straightforward. Now let's look at the next question. You have to find the sum of the series. Sum of the series, you show it to me. I'm going to tell you only one method to solve this particular question without getting into the intricacies. Now the actual method is also not very difficult because it is into 3 plus 1. But if you look at it, 7 by 2, 19 by 6, 37 by 12, what are these denominators? 2 multiplied by 3 multiplied by 2 doesn't make any sense, right? But if you look at 2, the gap is 4, the gap is 6, you can see that the gap is increasing. That will tell you that we are looking at 1 into 2, we are looking at 2 into 3, then we are looking at 3 into 4, and so on and so forth till the time we reach 4830. Now you have to understand what is 4830. How can you write 4830 as a product of two consecutive numbers? Now one way in which you can think about it is, okay, you know that 4830 is very close to 70 square, right? It is very close to 70 square or 4900. Also it ends in a 0. So you know that it has to be slightly less than 4900 and it has to be a product of two consecutive numbers. So the immediate suspect in front of me is 69 into 70. Now if you look at 69 into 70 and see what happens, you will see that 7 9s are 63, 7 6s are 42, plus 6 is 48, 4830, brilliant. So you know that we are going to look at these terms till we reach 69 into 70. So that basically tells me there are 69 terms in this series. Now, do I need to be bothered about all those things? Absolutely, yes. I need to be very clear about what am I doing in this particular context, right? But if you look at what is happening here, each term is 3 point something, 3 point something, 3 point something, and so on. And the remaining part, if you remove 3, is a very small number. So earlier it was 3 plus 1 by 2. Then it became 3 plus 1 by 6. Then it became 3 plus 1 by 12. So that term is reducing. So I will have 69 instances of 3 each, which will make my answer 207, and it will be an improvement over that because there are some smaller terms that I'm going to add. I don't care about the smaller terms at all. Now if you look at the options that we have here, 14559 by 70, if you are having trouble doing this, you can simply multiply 70 by 207 and see what happens. So 70 into 200 is going to be 14,000, 14,000 plus 490. So we are very close to this. So this absolutely should be my answer. In this context, if you divide it and see, you will get something which is way beyond 207. Even this one will be way less than 207. And this one will be extremely beyond 207. So if you use the calculator and find it out, you will be able to get option A as the correct answer for the sum of this particular series. So whenever you see sum of a series, make sure that you're looking at it in this kind of a manner so that you're reducing your calculation by a lot. Let's look at this one now. xy plus zy equals 37 and xz plus zy equals 72. Now this is what we have. So what can we understand from this? So a lot of people will try to take something common, then you will try to take values and then you will try to solve this. But we also know that x, y, z are positive integers. So that can also make our life slightly easier, and we will try to make our life easier by using that very approach. So we have xz plus zy equals 72 and xy plus zy equals 37. Now this is what we have in this context. Now if you look at this particular expression, you will get y into x plus z equals 37. Which basically means that one of these has to be 1, one of these has to be 37. But if x plus z equals 1, one of them becomes 0, but everyone should be a positive integer. That tells me that y is definitely equal to 1. That also tells me that x plus z equals 37. So I have got one observation here, x plus z equals 37. Now if I put y equal to 1 here, what am I going to get? Xz plus z equals 72. Or in other words, z into x plus 1 equals 72. Right? Z into x plus 1 equals 72. I can also manipulate this by a bit and say that, okay, x plus 1 plus z will be equal to 38. So I now need two numbers whose product is equal to 72 and whose sum is equal to 38. And if you have done your quadratic equations well, you will know that this product is going to be 36 and 2. Now the question is, how many values of x plus 1 are possible? X plus 1 can be equal to 2, x plus 1 can be equal to 36. And depending on that, the value of z will either be 2 or 36. Y could take only one value. So we need not even find the actual values. We will just need to know that there are two triplets that are possible. One wherein if I want to find the values, I can say that x plus 1 equals 36, x equals 35, which basically means z will be equal to 2 and y will be equal to 1. So y equals 1, z equals 2. The other way is x plus 1 equals 2, which makes x equals 1, which basically makes z equals 36, z equals 36 and y equals 1 again. So that is basically how we will go about it, and that's why the correct answer to this question will be two triplets that will be possible. Let's look at the next question now. The number of polynomials of the form y cube plus ay square plus by plus c which are divisible by y square plus 1. So it's a very painful question, right? But the important thing here is that it is divisible by y square plus 1. And how do you figure it out if it's divisible by y plus 1 and what exactly is possible? Some people will try to use synthetic division and so on and so forth. But you have to understand one very simple thing. I have this here, y cube plus ay square plus by plus c. This is equal to y square plus 1 into something. Now, if the order of this is y cube and y square plus 1 is present, there has to be a y that should be present here. And it should be followed by a constant term because we cannot have any y square, y cube or something. So this should be followed by a constant term. Now the constant term in this case should be a product of this number and this number, which means that this should be y plus c. Now if you expand this, you will see something funny happening, right? So in this context, if you just expand this, you will see that y cube plus, you can say cy square plus y plus c. This is what I'm going to get, right? So in this particular context, if you are looking at all the variances that are possible, you will be able to see that a will be equal to c, b will be equal to 1 and c is of course equal to c. So we have to figure out all the cases wherein a equals c, b will obviously be equal to 1, b cannot take any other value. So a equal to c, in how many cases is it possible? 1, 2, 3, 4, 5, 6. So a and 6, c can take any of these 6 values. So the correct answer here is going to be 6. Let's look at the next question now. You have to find the sum of all the digits in the integers from 1 to units, tens, hundreds, thousands, 10,000s and lakhs, right? 1 lakh. So you have to find the sum of all the digits in the integers from 1 till 1 lakh. Now how do you do this? So a lot of people might start thinking about 1s, 2s, 3s and so on and so forth. But the actual answer or the way in which you solve this is much more elegant. So look at this. You have 0, you have 1, you have 2, you have 3 and so on and so forth. You also have 9, 9, 9, 9, 9. You have 9, 9, 9, 9, 8. You have 9, 9, 9, 9, 7 and so on. You can see that the sum of the digits of these two is 45. The sum of the digits of these two is 45. The sum of the digits of these two is 45 and so on and so forth. Now the question is, how many such pairs are there? You just have to figure out what is this and what is this. So these two will basically constitute 1 lakh terms. So can I say that there are 50,000 instances of total being equal to 45? Right? So whatever happens, we are going to get 50,000 instances of 45. But our count doesn't stop here. We also have to add 1 lakh, which basically means we also have to add 1 to it. And that is basically our answer, right? Basically our answer. 45 into 5 is 225, followed by 3 zeros, followed by a 1. So our answer is 225, 00001. That's it. We need not sit and count all the digits. We need not sit and count all the single digit numbers, 2 digit numbers, 3 digit numbers, not required at all. Just have to form pairs. And if you can see 45s happening, that will make your life much easier in this particular case. So let's look at the next question now. Now we are moving on to geometry. So in this figure, ABCD is a square and there is a semicircle that has been drawn having DC as the diameter. ON is a tangent and it is at point F and it meets BC at point E. DF meets BC at point E. You have to find the measure of this angle FNE. Right? So you have to find the measure of this angle FNE. Now there is a very simple construction that you will have to do. So let's say this is the center of this particular semicircle. So I will just join O and F. Now OF is perpendicular to ON because we know that ON is a tangent. So this will be 90 degrees. This will also be 90 degrees, which basically tells me that this is a cyclic quadrilateral, which tells me that this angle ONB, right, ONB or FNE that we are expected to find out is equal to this angle, which is FOC. So I will say angle FNE equals angle FOC. That is what I will say. But I also know that angle FOC is a central angle. And this is basically, you can say twice of this angle, right? So FOC is equal to twice angle FDC. But we know that angle FDC is 30. So FNE becomes 30 into 2, that is 60. So the correct answer here is option C. That is 60 for this particular question. So you can use cyclic quadrilateral and inscribed angle theorem instead of getting into all kinds of variables and so on and so forth. Let's look at the next question, again from geometry. You have O, P, Q, R being the centers of these circles. We also know that the length of the segments OP, OR and PR are 98, 92 and 170. You have to find the radius of the circle with center O. Now it might seem to be a bit daunting. People might think about medians, circumcenters and whatnot. But if you look at it very simplistically, you just have to concentrate here, right? So we are looking at this. We also know that if I expand this, then this will be the radius. If I expand this, it will be the radius. Now what do we know? We know that the length of the line segments OP is 98. So let's say the radius of this circle is A, the big circle that we have, right? That is what we are saying is going to be A. Let's say that, this part, let's say the radius of this circle is A. Let's say the radius of this circle is B. What do we know? We know that this segment will be A plus B. So we have a couple of things here. Now OP we know is 98, right? OP is 98, which basically means the entire radius minus A. So let's say, for example, the radius of the larger circle is R. The entire radius minus A is going to be equal to 98. The entire radius minus B is going to be equal to 92. And we also know that A plus B is going to be equal to 170. We have to find the value of R. How do we do it? So basically what you can do is you can add these two. You are going to get 2R minus, if I take common, A plus B will be equal to 98 plus 92, that is 190, right? Which basically means 2R minus A plus B, which is 170, will be equal to 190. So 2R will be equal to 190 plus 170, that is 360, or R will be equal to 180. So if you just observe the segments here, you will be able to do it. There is no need to get into any kind of Pythagoras theorem or any of these things wherein you will try to find out P, Q, R and then you will try to figure out what is the circumradius or something like that. You don't need to do all those things at all. Let's look at the next question, and we are almost midway through the session now. So let's see what happens here. Now this is a question that you have to solve earlier and then have a look at the solution because it's very interesting. So now that you have solved the question and are looking at it, spoiler for you, the answer is not 48. Because a lot of people fall into this trap and they figure out that, okay, if one part is 24, the other has to be 24. But it is not the case. You have to form a quadrilateral. You are not expected to form a square. So now if you look at what is happening in this particular context, the quadrilateral is inscribed in a circle of radius 5 centimeters. So let's say the diameter is 10. We also know that the two adjacent sides of the quadrilateral are 6 centimeter and 8 centimeter. Now you will see that this is a nice right angled triangle, right? So if I join the two opposite vertices, it is 10, which is also the diameter. So this is fine. So the area of this triangle will be half into 6 into 8, that is 24. But a lot of people replicate this on the other side and then get the answer. But this has got nothing to do with the other side. What we have to understand is, if the other side is what we are looking at, there needs to be this point somewhere. It could be here, it could be here, it could be here, it could be anywhere. Now, the area of the other triangle is going to be half into the base 10 into the height. Now, what is the maximum possible height of this triangle? it is going to happen when the height or the vertex is directly above the center, which basically means that the height is going to be the radius. So in this case, the maximum possible area of the other triangle is going to be half into 10 into 5, that is 25 square centimeters. Overall, the maximum possible area is going to be 49 square centimeters and not 48 as some of you might have found out. Let's move on to the next question. Let's see what we have here. Now this is a rather complicated question, so do try this out and then have a look at the solution, because there is a significant amount of drawing that you will have to make. So make sure that you draw this, try this out, and then you have a look at the solution that's going to follow. So let's draw the diagram and see how we are able to go about this one. So first of all, ABCD is a square of side 1 unit. So let's draw it like this. Let's say this is ABCD. So I'll just write ABCD here. We also have another square BDEF. Now BD is the diagonal of this square. So we are supposed to draw another square BDEF. So we will draw it something like this. So this is BD, this will be E, and this will be F. Now this has been drawn. Similarly, two more squares BEGH. So BEGH. So these two get joined and I will get a square like this. So BEGH. That will be the next square, and EHIJ. Now EHIJ, of course, these two will get joined, and again you will get one more bigger square that we have here. Now we have got this, and we know that this is EHIJ. So this is I, this is J. You have to figure out the maximum possible area of triangle AIJ in square units. Now how do you figure this out, right? It looks like a very awkward diagram. So you do something which is slightly intuitive, but you complete this rectangle, right? So let's say you complete this rectangle. You just draw this and you extend this line as well, and you basically finish this entire rectangle. And now you are supposed to find out the value or the area of triangle AIJ. Now how do you do that? And the maximum possible area has been asked. That is purely because you could have drawn BEGH on the other side as well, and that would have led to a smaller triangle. But because we are drawing it in this direction, that will give us the largest value of the triangle AIJ. So in this case, if you look at what is happening here, right? So you will see that, okay, we know that ABCD is a square of side 1 unit. Now if this is side 1 unit, then we know that BFED will be of root 2, but then we don't need to bother about that, because we know that this will be of 2. And because of the symmetry that we have here, if this part is 2, this part is 2, I know that if I join these two, the length will also be equal to 2. Similarly, if I look at vertically, HG is 2. So if I look at this, then this part will be equal to 2. And of course, if I just extend it here, or if I just fold this thing, then I will get this part also equal to 2. And once I get all these things, I am mostly sorted, because I know that the area of this rectangle is going to be 5 into 4, that is 20. So 20 is going to be the area of the rectangle. And out of that, if I remove these three triangles, then I am sorted. So let's look at this AI and AJ, right? So if I look at AI and this triangle that is formed, I know that the base is 5, the height is 2. So half into 5 into 2, or 5 will be subtracted. This is one of the triangles. So I'll put it as triangle 1. Then I'm also looking at this triangle. Now, of course, if you are looking at this block, this will be 2, this will be 3. So if I'm looking at this triangle, what will be the area? Half into 2 into 2, which is again going to be equal to 2. This is the area of triangle 2. And if I look at this triangle 3 that I have, AJ and this one, I will say that the base is 3 and the height is 4. So I'll be able to cancel this out and it will be equal to 6. This is triangle 3. So what is the remaining area? That will be the area of triangle AIJ. So 5 plus 2, 7 plus 6, 13. Out of 20, if you remove 13, you will be left with a 7, which is going to be the answer to this particular question. So the shortcut here, or the way in which you look at this, is basically visualizing things in a slightly different manner, and that should help you solve this question quickly. Let's move on to the next question now. Look at this, think about this, then answer the question. The minimum number of lines required to obtain 16 non-overlapping parallelograms. So a lot of people make this mistake that they think that, okay, if I have 2 lines, I'll be able to, or if I have 4 lines, I'll be able to draw one parallelogram. If I have 5 lines, then I will be able to draw 2 parallelograms and so on and so forth. But we have to look at 16 non-overlapping parallelograms and minimum number of lines, which basically means that I should have 4 by 4 grid that I'm looking at. So how many lines do I need to draw now? I have already drawn them. 5 vertical lines, 5 horizontal lines. So that basically means that if I have, let's say, 10 lines, then I will be able to form 16 non-overlapping parallelograms. So just understand this, non-overlapping is key here. If overlapping would have been allowed, then my answer would have been slightly different, because if I have 4 lines, I'll be able to make 1 parallelogram. If I have 5 lines, I'll be able to make 1, 2 and 3 parallelograms. So that you have to understand. And why is this 3? Purely because I have to choose any one of these 3, and I have to choose any one of these 2, which can be done in 3 ways. So that is how you would have got overlapping parallelograms. But read the question very carefully. There is a subtle trap in this: non-overlapping parallelograms. So no 2 parallelograms can overlap with each other. That is what you have to look at. Now, talking about elegant solutions, there is this one question which has a very good, nice, elegant solution. And of course, there is a good conceptual solution as well. So we will try to look at the conceptual solution first, and then we will have a look at the elegant solution. You try it out on your own, and then we will look at this. So now if you join, let's say, C1 and C2, and if you join C1 and C and C2 and D, you will see that there is this nice right angled triangle that you are going to get here. So let's say, for example, we call this E. So the right angled triangle is going to be C1, C2, E. Now if you look at C1, C2, this line, it is going to be sum of these 2 radii. So this radius will be 12, this radius will be 3. So I can say that 12 plus 3, that is 15 square, will be equal to what? I will be able to say that C1E. Now what is C1E? It is basically this radius minus this radius. So you will get 12 minus 3, that is 9 square, plus EC square. But we can see that EC to DC, this part that I have drawn right now, that is a rectangle. So EC square will be the same as CD square, right? Which basically is CB plus BD. We'll have a look at it, but CD square is what we have got here. Now, of course, 15 square, 9 square, you know that CD should be equal to 12 because it's a Pythagorean triplet, 9, 12, 15. But we can say that this point B is the point from where we have 2 tangents to the circles. So CB should be equal to AB should be equal to DB, which basically means that the length of AB is going to be half of CD, or 6 centimeter. So the correct answer here is option C for this question. Is there a better way of solving this? There indeed is. So if you look at this part, you are saying that, okay, C1 and C2 need to be joined. Now just by looking at the figure, you will realize that C1, C2 is greater than CD, which basically means that C1, C2 will be greater than twice AB, or in other words, AB will be less than C1, C2 by 2. But what is the value of C1, C2? It is 12 plus 3, 15. So AB has to be less than 7.5. How many options do we have that are less than 7.5? Only one. So the correct answer here is option C, that is 6 centimeters. By pure observation, you will be able to get this question right very quickly. Let's look at the next one. Slightly difficult to understand question, but try it out and then we will have a look at the solution. Now, the angles of a convex pentagon are in an AP. Now, pentagon and convex basically means that no angle will be greater than 180 degrees. So something like this is what we're looking at. Now, they are in an arithmetic progression. So by now, if you know that if I have 5 angles and they form a pentagon, the sum of these angles should be equal to 360 plus 180, that is 540. If they are in an AP, the middle angle has to be the average. So 540 divided by 5, right? So the middle angle that I'm going to have is going to be 108. Let's say, for example, the 2 larger angles are 108 plus D and 108 plus 2D. And the 2 smaller angles are 108 minus D and 108 minus twice of D. Now we have to understand which can never be the value of any of its angles, and we have some very small numbers that are present here. Now we know that any angle cannot be greater than 180 degrees. That is what I know for sure. So the largest angle that we have, 108 plus 2D, this has to be less than 180 degrees. Or we know that 2D has to be less than 72, or D has to be less than 36. Now if D is less than 36, what is the value of these things that we can get, right? So if D is equal to 36, let's say, for example, then what am I going to get as the value of this part? 108 minus 2D. So 108 minus 2d is what we have here. If d equals 36, so 108 minus 36 into 2 will be equal to 36. But this is not allowed. In fact, you can also change the inequality here and see what happens. So d is less than 36, minus d will be greater than 36. Minus 2d will be greater than 72. 108 minus 2d will be what in this particular context? That is what you have to understand. So sorry, minus d is greater than minus 36. Minus 2d is greater than minus 72. So if I am adding 108 to both sides, 108 minus 2d has to be greater than 36. So the smallest angle that I have has to be greater than 36, which means that 36, 35, 34 are all not possible, and so can never be the value of any of the angles of this pentagon that we are looking at. Let's look at the next question now. Now this is again a very interesting question, and especially if you read it well and if you understand the mathematics behind this, it's very easy for you to understand. And of course, if you can do a bit of guesswork, little bit of guesswork if you can do, you will still be able to handle this nicely. Now we have to understand one thing. In any triangle that we have, and if you haven't had a look at the triangles video, do have a look at it. If I have these three medians, then each median will be divided in the ratio of 2:1 by the centroid, and all these triangles that I have will be equal in terms of area. Now, if you know these two things, you will be able to answer this question really nicely. Now, you know that, okay, this is basically CP and BQ are the medians is what I know. So this triangle will have area equals X, right? This triangle will have area equals X. That is what I know. I also know that this is to this is going to be 2:1. That is what I know here. Now, each of these triangles is equal in area, which basically means that these triangles are all equal to 1/6 of the entire triangle. So 1/6 into 900 root 3 will be the area of these triangles that we have. But we can see that this base is 2 units, this base is 1 unit, they share the common vertex, so the height will be the same for both the triangles. So I can say that this area is going to be half of this. So half into 1/6 into 900 root 3, you can just cancel out 12, 7s are 84, 12 5s are 60. The correct answer is 75 root 3. The other thing you can think about is 900 root 3 will have to be divisible by something, right? So if I take the area of the shaded region as 64, then I will not be able to double it and say that it will add up to 900 somehow, because 900 is not a factor of 64 is not a factor of 900. 80 is not a factor of 900. 72, if you look at it, what do you get? 9 8s are 72 and 100. 100 by 8 again will not give a nice factor. But 75 definitely is a factor of 900, which again makes it clear that option C should be the correct answer to this one. Let's look at the next question now. A, B, C, D, E, F, G, H is a regular octagon. A lot of people look at octagon, get scared and run away, but don't do that. You have line segments AE and CF that intersect at the point K. So first of all, let's draw this octagon and see what happens. Right? So we have to join AE and CF in this particular context. So let's say, for example, we are starting from here. So A, B, C, D, E, F, G and H. This is the regular octagon. Now AE is what we are supposed to draw and CF is what we are supposed to draw. Now these intersect at the point K. Now if AB is equal to 1 unit, you have to figure out the length of the segment CK. So what is the length of this segment CK is what we are expected to find out. Now we know that if we are drawing something like this, then of course there is going to be some construction that might be possible, something that we might be able to use to answer this particular thing. So in this particular context, there is one thing that you can maybe look at. You can try to complete this entire square, because an octagon is formed when you remove the corners from a particular square. So now we have formed this particular square. What can we say about this particular square? We know that AB is 1. That will mean that BC is also equal to 1. That will mean DE is also equal to 1. So this is the first part that we have got here, right? What else can we understand from this? We also know that because the angle of a regular octagon is 135 degrees, this will be a 45, 45, 90 triangle with hypotenuse equals 1. So now the hypotenuse will be equal to 1. It will be a 45, 45, 90 triangle that we are going to have. And again, we have to find the value of CK, which basically means If you are able to find the value of kf and we can subtract it from cf, we should be able to get the answer. And by now the value of cf will also be very clear, because we know that it's 1 by root 2, 1 by root 2. So that will make your life much easier. That way you can figure it out very easily, very nicely, right? So that is what we will attempt to do in this particular context. Because this is 1, this part becomes 1 by root 2, this part becomes 1 by root 2, because it's a 45, 45, 90 triangle. That is what we have here. So what can we say is the length of CF now? The length of CF will be 1, which is DE, plus 1 by root 2 plus 1 by root 2, which is 2 by root 2. Or in other words, it is 1 plus root 2. So the value of CF is going to be 1 plus root of 2, which approximately translates into, you can say 1.4 plus 1, that is 2.4. My answer has to be less than 2.4. In fact, my answer has to be less than half, so it has to be somewhere around 1.2ish, hopefully, right? That is what we are looking at in this particular context. But if you look at this particular set of options that we have, or we want to find CK, so it will be slightly more than half. That is what we are looking at. So it will be slightly greater than 1.2, because if you look at the diagram, you will see that CK is greater than KF. That is what we can see. Now, if you look at the options, 1.732 minus 1 is 0.7, doesn't work. 3 upon root 2, 3 upon 1.4 will be 2 point something. This will definitely not work. What about this one? Root 2 plus 1 divided by root 2, which will be 1 plus 1 by root 2, which will be 1.7ish. And this is root 2, which is 1.4ish. Now, if this part is 1.7ish, then that leaves us with 0.7 here. And if this part is 1.4ish, this leaves us with 1.4 here. So which one is the closer one that you have to look at? So you can either go for C or D by using this method. But if you want to be even clearer and you want to do it well, you know for sure that if you are looking at this particular segment EF, sorry, not EF, this is 1 for sure. So this again will be 1 by root 2. This again will be 1 by root 2. Now, because this is very much in front of 1 by root 2, you will know that this is also going to be approximately equal to 1 by root 2 is what you can say, right? That is what you're looking at. We can also say that this segment will be slightly less than 1 plus 1 by root 2. And if you do this, you will be able to get that it has to be slightly less than 1 plus 1 by root 2 or root 2 plus 1 by root 2. It has to be slightly less than option C. So the correct answer here is going to be option D for this one, right? So if you just observe the numbers, you will be able to get this and should not be a problem at all. That way you'll be able to get it even without calculating the values. So I know for sure that CK has to be slightly less than 1 plus 1 by root 2 or root 2 plus 1 by root 2, which means C cannot be my answer. And the other two are either too small or too large. So of course, those are not going to be our answers to this question. So that is basically how you can solve this using a slightly quicker method by looking at numbers nicely. Let's move on to the next part now. Now we are going to look at some bits from number theory. Now Z is a positive integer. You have to find the smallest possible or positive integer m such that 2 raised to 3z always divides m raised to 3113 plus 1. Now what will you do in this case? Just assume that z is a positive integer. Let's say z is equal to 1. That's it. If z is equal to 1, what do we get in this context? Then it means that 8 should always divide m raised to 3113 plus 1. This number has to be divisible by 8. Now this part is going to give me remainder 1. So this part has to give me remainder 7. Right? So m raised to 3113 should give me a remainder 7 when I divide it by 8. Now when can I get this? Let's say for example, I put m equals 1. It is definitely not going to give me a remainder 7. What if m equals 2? There is a problem because this part will never give a remainder of 7 when divided by 8. In fact, this number has to be odd because odd number plus odd number will be an even number which might be divisible by 8. But if this is even, definitely the entire thing is not going to be divisible by 8. So I know that m has to be an odd number. Now if I look at 1, 3, 5, 7, 1 obviously is not going to be possible. What about 3? 3 raised to whatever divided by 8 is never going to give me remainder 7 because the remainder has to be at least or it has to be less than the divisor that we have there, right? So it cannot really give me remainder 7 if the number itself is 3. Right, that is one thing that we are looking at, and there will be a cyclicity that will also be present here. So in case of 3, if you just want to look at the cyclicity, 3 raised to 1 gives remainder 3, 3 square gives remainder 1, 3 raised to 3 gives remainder 3, and so on and so forth. So 3, 1, 3 is what we are looking at. What if it's 5? 5 raised to 1 will give remainder 5, 5 square will give remainder 1, 5 cube will remainder 5, and so on. What about 7? 7 raised to 1 will give remainder 7. 7 square, 64, 49 divided by 8 will give remainder 1. Then 7, then 1. There is a chance that this might happen. So what we are saying in this context is m has to be equal to 7. That will be the smallest positive integer m, such that m raised to 3113 plus 1 will be divisible by 8. Because this is an odd power and this is an even power, our logic is justified. So if I put z equals 1, I should get my answer as 8. Z equals to 1, 5, not my answer. Z equals 1, 3, not my answer. Z equals 1, 1, not my answer. Z equals 1, 8 minus 1, 7. Yes, that is my answer. And that is basically how you can look at this particular thing. You can assume values and do it nicely. Let's look at the next question now. Now this is again something that is based on remainders. 1 raised to 7 plus 2 raised to 7 plus 3 raised to 7 till 100 raised to 7 is divided by 202. Now instead of getting into the whole form of, okay, we are looking at AP raised to an odd number and so on, you basically combine the extreme terms. 1 raised to 7 plus 100 raised to 7, 2 raised to 7 plus 99 raised to 7, and so on till the time you reach 50 raised to 7 plus 51 raised to 7. This is what we are looking at here. Now if you combine these two, we can say that it is a raised to n plus b raised to n, where n is odd. In this case, what will happen? It will be divisible by a plus b always, which means this group will be divisible by 101, this group will be divisible by 101, and so on. How many such groups will we have? We will have 50 groups that are going to be 101 multiplied by something. Alright, that is the first thing. The second thing we have to understand is that if we are adding 1 raised to 7 and 100 raised to 7, it is an odd number plus an even number, which is going to be an odd number. So we can say that it is 101 into an odd number. But there are 50 such groups and every group will basically have something even into something odd, which basically means if you remove 101, you will be multiplying it by an even number, which will ensure that it was divisible by 202. So in this case, 1 raised to 7, 2 raised to 7, 3 raised to 7 till 100 raised to 7. If you simply combine the symmetrical terms that we have there, you will be able to say with certainty that we are getting 50 groups, each of which is going to be 101 multiplied by some number, some odd number. And because it's 101 multiplied by odd number 50 times, it will effectively be 101 into an even number, which means that it will be a multiple of 202. So that is how you will solve this particular bit. Let's look at the next question. A very interesting question. So try this out and then you can have a look at the solution. Now given that a raised to 5 plus b raised to 5 plus c raised to 5, where a, b, c are distinct digits, very important, and 6-digit number is formed. So we know that these are all single digit whole numbers, you can say, right? So single digit numbers is what we're looking at, and we are raising everything to 5. And when I'm raising stuff to 5, effectively it ends up getting added to a number that ends in a 9. Now that is what you have to understand. So a raised to 5, any number raised to 5, 1 raised to 5 will end in a 1, 2 raised to 5 will end in a 2, 3 raised to 5 will end in a 3, and so on till the time you reach 9 raised to 5 or even 0 raised to 5 for that matter, which will end in a 0, 9 raised to 5 will end in a 9. This is what we have got now. Now, we have to figure out A, B, C, right? What is the maximum possible value that can happen in this particular context, right? So A, B, C are all distinct numbers. So at most what is going to happen? 9, 8, 7 could be the last digit, right, of a raised to 5, b raised to 5, c raised to 5, which basically means that my number is going to end in a 24. That is what we're looking at. But my number ends in a 9. So what can be the sum of the last digit of these three numbers, a raised to 5, b raised to 5, c raised to 5? It's either 19 or it is 9, one of these two. Now let's say, for example, we are looking at the largest possible distinction that we can get here, right? So let's say, for example, I am going to look at this 9 and I'm going to look at this 19, let's say. So how can I get 9 in the largest possible manner, or split it in such a manner that a raised to 5 plus b raised to 5 plus c raised to 5 is the largest? I'll basically write it as 8 raised to 5, 1 raised to 5 and 0 raised to 5. This is the best split that I can do, because if I split it as 3 raised to 5, 3 raised to 5, 3 raised to 5, which is what I had mentioned in one of the previous questions, you will see that the number is not that big. So 3 raised to 5 is 3, 3s are 9, 3s are 27, 3s are 81, 3s are 243.
and into 3 will give me 729, which is way less than wherever we are here. Similarly, 8 raised to 5, 1 raised to 5, 0 raised to 5 will be a significantly larger number. Now you can use the on-screen calculator, or you can simply say that this is 2 raised to 15. 2 raised to 10 is around 1000. 2 raised to 11 will be 2000. 2 raised to 12 will be 4000. 2 raised to 13 will be 8000. 2 raised to 14 will be 16,000. And 2 raised to 15 will be 32,000. But it is nowhere close to 91,000, which is way ahead. So this is definitely not going to be satisfactory for us. That will tell us that the value of a plus b plus c has to be equal to 19. We need not find the actual value. We can just say that a plus b plus c equals 19. Now if you look at this number and divide it by 11, you are supposed to look at the sum of the odd placed digits and the even placed digits. The sum of the odd placed digits is 2 plus 5 plus 1, that is 8. And sum of the even placed digits is a plus b plus c. By happenstance, it is 19. What is the difference between these two? 11, which is divisible by 11. So we can say with certainty that if you divide this number by 11, our answer is going to be 0, because there will be no remainder when you divide this number by 11, as it is already divisible by 11. So that is something that you have to understand in this particular case. You need not find the values of a, b, c. We don't care what the value of a, b, c are. We just want to see a plus b plus c. What is the value of that part? Let's move on to the next question. Try this question out on your own. It's a very simplistic question. Try it out and then have a look at the solution that's going to follow. So in this context, you have to understand that whenever you find the HCF of something, all the factors of the HCF are also going to be the common factors for these two numbers. So in this context, 30 raised to 11 and 20 raised to 13, if you just split it, you will be able to see that 30 is nothing but 2 into 3 into 5. So 2 raised to 11 into 3 raised to 11 into 5 raised to 11. What about 20 raised to 13? This will basically be 2 square into 5 raised to 13, or 2 raised to 26 into 5 raised to 13. How do we find the HCF of these two numbers? We write down all the common or the factors that are there and we raise them to their smallest possible power. So 2 raised to 11, 2 raised to 26, I will write it as 2 raised to 11 because 26 is the larger power. What about 3? 3 raised to 11, 3 raised to 0, I write it as 3 raised to 0. And 5 raised to 11, 5 raised to 13, I write it as 5 raised to 11. That basically tells me that the largest, the highest common factor, HCF of these two numbers is 2 raised to 11 into 5 raised to 11. So all the factors of 2 raised to 11 into 5 raised to 11 will be the factors that will be common to 30 raised to 11 and 20 raised to 13. How many factors does this have? It's going to be 11 plus 1 multiplied by 11 plus 1, or 12 into 12, that is 144. So there will be 144 factors that will be common to 30 raised to 11 and 20 raised to 13, and that should of course be the answer to our question as well. Now we will look at an extremely interesting question. So try this out on your own. Maybe you will struggle with this a bit, but I'm sure that the solution that I'm going to share with you, you are going to enjoy that a lot. You might have some questions, but I think it is a very enjoyable solution. So let's see. Now, a lot of you might have used Chinese remainder theorem to do it, and you would have said that, okay, I need to find a number in the form of 7a plus 2, 8b plus 4, 9c plus 6, and then you would have struggled with a, b and c, balancing those things. But you have to understand one thing here. Now, what is the number that you can say which is the smallest such number and is completely divisible by 7, 8 and 9? You can say that it is LCM of 7, 8, 9, which will come out to 504. So 8 sevens are 56, 56 into 9, 450 plus 54 is 504. Now, let's say for example, I am trying to figure out a number that leaves a remainder 6 when divided by 9, right? What is the smallest such number in this particular context, below 504? I can say 501 is a number. Now 501 when divided by 9, right? When 501 is divided by 9, it leaves remainder 6. But when 501 is divided by 8, what is the remainder that it will leave? We have gone 3 places backward. So 5 will be the remainder when you divide something by 8. And if I divide this number by 7, what will be the remainder? Again, we have gone 3 places backwards. So it will be 4. But what are the remainders that I need? I need 6, 4 and 2 to be the remainders. So what has to happen is the gap has to increase twice. Now in this particular context, you take 6 as the anchor. That essentially tells me that if I take something back by 9, the remainder is always going to be 6. So 509, if I make it 492, if I make it 483, if I make it 474, the answer when I divide this by 9 is always going to be equal to 6. right? So this will always follow. I have to look at those instances wherein I am going backwards and the remainders when divided by 8 and 7 are 4 and 2 respectively. Now think about it. If I am already here and if I am going back by 9 spaces, it basically means that my remainder will reduce by 1. How am I getting this? Because I am going 9 places backwards, which means I am going 8 places backwards, which will leave the exact same remainder. But then I am going back one more place. Now, if you're not able to understand this, take a smaller number and see what happens. Let's say, for example, there is a number that leaves remainder 5 when divided by 18, right? So let's say 13 divided by 5 leaves remainder, 13 divided by 5 leaves remainder 4, 13 divided by 8 leaves remainder 5, let's say. Now go back 9 places. What will you get? You will get 4 divided by 5. Now 4 divided by 5 is remainder is 4. Why am I getting this? Because out of 13, if I removed 8, my remainder would not have changed. But I have removed 8 and I removed one more, which basically means my remainder will fall by one more. So 5 will become 4. Now if I had a number which gave a remainder 4 when divided by 7 and I'm going 9 places backwards, 7 would not have made a difference. But I am going 2 more places backwards, which means that my remainder will fall by 2. So the answer to this question is very straightforward. I just have to do 501 minus 9, that is 492, which will also be the answer to this question, right? So 492 when divided by 9, of course the answer is going to be 6. 492 divided by 8, 8 6s are 48, 12, remainder is 4. And 492 divided by 7, 490 plus 2, again the remainder is 2. So in this case, you just have to look at 504, work slightly backwards, have an anchor number, and then look at how the remainders change. That is what you have to look at. If you do this, then you should be fine. So I hope you enjoyed this particular method instead of going for Chinese remainder theorem. Let's look at the next question now. Now in this question, if you are looking at it, 1 upon 1 factorial into 19 factorial, 1 upon 3 factorial into 17 factorial, and so on and so forth, right? So this is basically what we are looking at in this particular context. And we have to write it as 2 raised to x upon y factorial, and we have to figure out what is the value of x plus y. Now, how do we solve this? Now, solving this might be slightly difficult. So what we can do in this context is we can just assume that we can see a 20, right, everywhere. So what will I do? I'll just multiply and divide by some number. In this case, it is going to be 20 factorial, let's say. So I will divide this by 20 factorial. I can say that I'll write this as 20 factorial divided by 1 factorial into 19 factorial plus 20 factorial divided by 3 factorial into 17 factorial, and so on and so forth till the time I reach 20 factorial by 19 factorial into 1 factorial. That is what we are getting. And this is equal to 2 raised to x upon y factorial. Now you have to understand that 20 factorial upon 1 factorial 19 factorial is going to be equal to 20 C1 plus 20 C3 and so on till the time I reach 20 C19. Now this is again equal to 2 raised to x by y factorial. But now you have to understand what exactly is this pattern. Now if you observe your patterns properly, you will know that NC0 plus NC1 plus NC2 and so on till the time I reach, let's say, NCn minus 2, NCn minus 1 plus NCn, this will be equal to 2 raised to n. Now this is the form that you need to remember. Now if you look at the chronology that we have here, we have NC1, then NC3 and so on till the time we reach NCn minus 1. So in this particular context, if you are looking at the symmetry that we have half the terms that are present and half the terms that are not present. So we don't have 20C0, we have 20C1. We don't have 20C2, we have 20C3 and so on and so forth till the time we reach 20C19. So this is basically going to be half of whatever you are going to get. So in this particular context, you should have got 2 raised to 20, but it is half of that. So my numerator will be 2 raised to 19 and my denominator will be 20 factorial. So in this case, the value of x will be 19, the value of y will be 20, the summation becomes 39. It is not among the options. So my answer here is rather surprisingly option D, that is none of these. So it will be 39 in total. Let's look at the next question now. What is the sum of all those factors of 1800 whose unit digit is 5? Now, if you don't know the sum of the factors formula, even then you will be able to do this. So let's first factorize 1800 and write it in a simplistic manner. Now, what is 1800? You can say that 1800 is going to be 2 into 900. 900 is 2 into 450, which is 2 into 225, which is 3 into 75, which is 3 into 25, which is 5 into 5. So I am going to get this as 2 cubed multiplied by 3 square multiplied by 5 square. This is what I'm going to get. Now my units place digit has to be 5. So what all options do I have? My factor when it comes to 2, right? The power of 2 can either be 2 raised to 0, 2 raised to 1, 2 square or 2 cubed. So that is my selection set. What about 3's? It can either be 3 raised to 0, 3 raised to 1 or 3 squared. What about 5's? It's either 5 raised to 0, 5 raised to 1 or 5 squared. So these are my selections that are available. But the unit digit has to be 5. Now what can I say from here? If the unit digit has to be 5, it has to be an odd number, which means that I cannot have 2 raised to 1, 2 raised to 3 or 2 raised to 2 as a part of that factor at all. So from this basket, I can only select 2 raised to 0. From this basket, I don't really care because 3 raised to 0, 3 raised to 1, 3 raised to 2, any one or many of them are there. It does not really impact my selection at all. And from the bracket that we have here, I cannot afford to have 5 raised to 0 because I need to have a units place digit equal to 5. So it has to be either 5 raised to 1 or 5 square. How do I find the sum of all the factors? I just put a plus between these and I just multiply everything. So I'm going to get this as equal to 1. 3 raised to 0 is 1 plus 3, 4. 4 plus 9 will be equal to 13. So this is multiplication. And the multiplication here is 5 square into 5, which is, or 5 square plus 5, that is 30. So 13 into 30 will be 390. So the sum of all those factors of 1800 whose units place digit is equal to 5 is going to be 390 for this particular question. Let's look at the next one. Now you have n equals 5 raised to p plus 1, 5 raised to q plus 1, 5 raised to r plus 1 and so on and so forth. Now you are expected to figure out what is the remainder when n into m is divided by 6 and you are expecting a numerical answer. So what should happen? It should be possible for any value of p, right? And we know that p, q, r are consecutive natural numbers. The value of p can be assumed to be 1. Now if the value of p is 1, n clearly becomes a multiple of 6. Why? Because 5 raised to p, 5 raised to 1 plus 1 is 6. So n is a multiple of 6. And whatever you do here, you are still going to get some number which when multiplied by n should be divisible by 6. So the answer in this question is going to be 0. The remainder when n into m is divided by 6 is purely going to be 0. You need not try for larger numbers. It has to be true for everything. So p being equal to 1 should satisfy this and we have no problems whatsoever marking 0 as the answer to this particular question. Let's move on to the next question. Now this is a tough one. If you don't understand this, then it will be very difficult to solve this. It looks to be a very difficult question, but the solution is extremely elegant. So look at this properly and then have a look at the solution. Now we have 2-digit numbers xy and the reversed number is also a 2-digit number. PQ and QP are also 2-digit numbers. So basically none of them will be equal to 0. That much we have figured out. We also know that xy into PQ is greater than yx into QP, the 2-digit numbers. And the difference between them is less than 100. So let's try to figure out what happens in this context and let's see what we are getting there. Now, we have been told that xy into pq. So let me write this as 10x plus y into pq, 10p plus q. I know that this is greater than yx multiplied by qp. So 10y plus x multiplied by 10q plus p. Now if I just expand this, I am going to get 10x into 10p, I can write this as 100xp plus 10xq plus 10py plus qy. This will be greater than 10y into 10q, so 100yq plus 10py plus 10xq plus px. Now you will see that you have 10py here, 10py here, 10xq here, 10x2 which will get cancelled out. So we can see that 10xp minus xp or 99xp and qy minus 100qy, which basically means minus 99qy, will be greater than 0. That is what we can see. Or we can say 99 into xp minus qy will be greater than 0. This is what we know. But we also know that xy into pq minus yx into qp, which was basically this thing, everything taken to the left hand side. This is less than 100. So I can also say that this is less than 100 according to the question, which essentially means that xp minus qy in this context will be equal to 1. Or you can say this value will be equal to 99. That is what we'll be able to understand. right? So that's what, if you are able to understand, then we just have to figure out what will be the last two digits of the product of yx and qp. Fine. So xy multiplied by qp will end in 8 and 3. So what will be the last two digits of the product yx into qp? And we have known the entire thing that this difference has to be less than 100. This has to be equal to 1, which basically means that this difference has to be equal to 99. So the difference has to be equal to 99. So xy into pq minus yx into qp, right? This should end in a 99. But we know that this part ends in 8 and 3. So 83 minus what will end in 99? That is what we have to figure out. So if 83 minus something ends in 99, then this part has to be an 84. Because 83 from here and 84 from the previous 100 will end up giving you a 99 in the first place. So in this context, if you are looking at the answer here, the second number has to end in 84, which will give you the difference as 99, or the last two digits as 99, which has to be the case here, because the difference has to be 99 in this particular context. You don't need to find out xy, you don't need to find out pq or anything. Just have to figure out how exactly does this work, and you will be able to get the answer very easily, I would say. Let's look at the next question now. Here you have A, B, C, D are 4 distinct natural numbers, each of which has exactly 5 factors. Now, when does a number have exactly 5 factors? It basically means that the number is in the form of A raised to 4, let's say, or P raised to 4, let's say, where P is a prime number. If P is a prime number and the number is in the form of P raised to 4, then we say that it has exactly 5 factors. So if A, B, C, D are 4 distinct natural numbers, let's say A is in the form of P raised to 4, B is in the form of Q raised to 4, C is in the form of R raised to 4, and D is in the form of S raised to 4, where P, Q, R, S are all distinct primes. Then how many factors will be there? 4 plus 1 multiplied by 4 plus 1 multiplied by 4 plus 1 multiplied by 4 plus 1. So we take the power plus 1. That is the shortcut. So 5 into 5 into 5 into 5, you will get 25 into 25 or 625 such factors that you will get of the product of A, B, C and D. Let's look at the next question now. You have to find the remainder when this entire sum is divided by 26. Now you have to understand one small thing here, that 3 raised to 100, 200, 300 until 10,000. So how many terms are there? There are 100 terms here. 26 is a very peculiar number. You know why? Because 3 cube is 27. So I know that 3 raised to 3 when divided by 26 will leave a remainder of 1. Which means that 3 raised to 6, 3 raised to 9, 3 raised to 12, all these numbers when divided by 26 will leave remainder 1. That is what I know for sure. Now if I look at this entire sequence, I need not use GP and try to figure out the actual sum. I can just figure out the cyclicity. So 3 raised to 100, you know that this can be written as 3 raised to 99 into 3 raised to 1. This part will give remainder 1 when divided by 26. This part will give remainder 3. What about 3 raised to 200? So this part or this term will give remainder 3 when divided by 26. What about 3 raised to 200? You can see it can be written as 3 raised to 198 into 3 square. Why 198? Because it is a multiple of 6 or multiple of 3. So what am I getting here? My remainder of the second term and divided by 26 will be 9. What about the third term? 3 raised to 300. It by itself will be divisible by 26, or it will give a remainder of 26, because every pocket of 3 terms will give remainder 1. So in this context, the remainder becomes 1. Now you can see that there is a nice cyclicity forming here. 3 plus 9 plus 1. Again 3 plus 9 plus 1. And this will happen 100 times. So I will have 33 instances of 3 plus 9 plus 1 and one final instance of 3. This I will have to divide by 26 to get my final answer. Now what is this? 9 plus 3 is 12 plus 1 13. So I am going to get 33 into 13 divided by 26 plus 3. Now you need not even divide this entirely and try to figure it out, because 13 and 26 can be cancelled out to get me a 2 in the denominator. 33 divided by 2 is definitely going to give me 1 as the intermediate remainder. But because I have cancelled out a 13, I will have to multiply it by 13, multiply it back by 13 to get 13 as the remainder of the first part. The second part will give me remainder 3. So the effective remainder is going to be 13 plus 3, that is 16. So the answer to this question is going to be 1, 6, that is 16. Let's look at the next one. How many 3-digit numbers A, B, C are there such that A greater than B greater than C or A less than B less than C? Now in this case, you will have to use a certain number of cases that are there, and that will kind of get you the answer very nicely. So let's see what we can do here. Now A greater than B greater than C or A less than B less than C, and 3-digit numbers are there, so A cannot be equal to 0. So in this particular context, let's say we are looking at a case wherein there are no zeros. If there are no zeros, then what can happen? We basically have to select 3 distinct digits, because greater than or less than exist. So no 2 digits are equal. So I basically need to select 3 digits from 9 digits, which can be done in 9C 3 ways, which will be 9 into 8 into 7 into 6 factorial by 6 factorial divided by 3 factorial, that is 6. So you will get 9 8s are 72, 12 6s are 72. So 84 such selections. Now as soon as I select 3 numbers, let's say for example I have selected 1, 3 and 8. Now either I can arrange them as 1, 3, 8 ascending order, or I can arrange them as 8, 3, 1 descending order. So for each of these cases, I will have 2 possibilities that will exist, right? So in this case, I will have 168 possibilities that will exist. But if there is 1 0, there cannot be more than 1 zeros. So if there is 1 0, what can happen? Can that 0 be here? Not really, because A cannot be equal to 0. It has to be a 3-digit number. B cannot be 0 because A is less than B. So this cannot be the case wherein you will get a 0 as a digit. But in this case, you can have C equals 0. B cannot be equal to 0. A cannot be equal to 0. Now if C is equal to 0, I need to select 2 digits. So out of the remaining 9 digits that we have, I will have to select 2 digits. So I'll be able to do that in 9C 2 ways, or 9 into 8 by 2, or 36 ways. So these are the number of ways in which I'll be able to select 2 digits. But now I will be able to arrange those 2 digits in only one manner, because A greater than B. So if I have selected, let's say 5 and 7, my number will be 750. It cannot be 570. So that basically means that I will get only 36 ways of doing this if there is 1 0 that is present, and 168 ways in which I'll be able to do it if there are no zeros that are present. So the total number of ways in this case is going to be equal to 168 plus 36, that is 204. And that will be the answer to this question. Let's look at the next question now. Very interesting question type. Some of you might know the shortcut, so you can use the shortcut. But for those of you who don't know it, I'll tell you what the shortcut is. You have to find the sum of all 4-digit numbers that can be made using the digits 2, 3, 5, 6. Now, if I were to write everything down, I can say that, okay, 2, 3, 5, 6 is a number that I can form. I can form 2, 3, 6, 5. I can form 2, 5, 3, 6. I can form 2, 5, 6, 3. I can form 2, 6, 3, 5. I can form 2, 6, 5, 3, and so on. Now, these are all in an ascending order. But you can't write down all these things. So you have to understand a simple thing. You can see that 2, 3, 5, 6 are all equally occurring. There is no condition whatsoever that has been given to us. How many numbers will be formed? 4 factorial numbers or 24 numbers will be formed. We know that in these 24 numbers, 2 will be present 6 times on the thousands place. 3 will be present 6 times at the thousands place, 5 will be present 6 times at the thousands place, and 6 will be present 6 times at the thousands place. So when I am saying 1000, I will have 6 occurrences each of 2, 3, 5 and 6. Similarly, when I am looking at the hundreds place, I will again have 6 appearances of 2, 3, 5 and 6 each. Similarly, when I am looking at the tens place, I will have 6 occurrences each of 2, 3, 5 and 6. And when I am looking at the units place, I will have 6 occurrences each of 2, 3, 5 and 6. Now if I add everything, what do I get? I get 1, 1, 1, 1 multiplied by 6. How did I get this 6? I divided 4 factorial by 4. Multiplied by, what is this? Sum of the digits. Now this is the shortcut, right? So you have to basically use so many ones that are there, multiplied by the number of digits in each number, which is 4. So 4 factorial divided by the number of different digits that we have. So 4 different digits. So each digit will appear 4 factorial by 4 or 3 factorial or 6 times. Multiplied by the sum of the digits 2 plus 3 plus 5 plus 6, which gives us 16. So in this context, what will be our answer? 1111 multiplied by 6 into 16 or 96 into 1111. You can just put it in your this thing in the on-screen calculator and you can easily figure it out. So 96 into 1 will be 96. 96 into 1 is again 96. Plus 9 is 105. So I'll write this as 10. 96 ones are 96 plus 10 is 106. 96 ones are 96 plus 10 is 106. So 106656 is going to be the answer to the question. This looks slightly complicated, but if you know the form, you can directly jump to this step. Now, I will tell you one more complicated question that uses the same thing. So in this particular context, what we are looking at is if you have 2, 3, 5, 6, let's say for example, then what do you do in that case, right? So because you had everything that was easily available, easily manageable, you could do it. But let's say I change the question by a bit and I say 2, 3, 5 and 0 are present. Now you have to find out what is the sum of all 4-digit numbers. Now some people get into it that, okay, 2 can be present in some cases, 3 can be present in some cases, 5 can be present in some cases, the rest of the things 0 will appear equally, and then you end up getting confused. What I will suggest that you do is you try to figure out the sum of all 4-digit numbers that can be formed using 2, 3, 5 and 0, which also include numbers that start with a 0. And from that you subtract the sum of all 3-digit numbers that you can form using the digits 2, 3 and 5. Isn't that an easier way of doing it? Because out of these numbers that we have got, what are we not comfortable with? We are not comfortable with the numbers that start with a 0, which basically means these will be 3-digit numbers. So then I can use the exact same formula that I had done earlier. So what will I do? 4-digit numbers, so 1111 multiplied by 4 factorial divided by number of digits, that is 4, multiplied by sum of the digits, 5, 6, 7, 8, 9, 10. So this is what we are going to get in this particular context, right? And this will basically be the first part that we are getting. So we are going to get 60 into 1111. I'll just write it here, 1111 into 60. Minus 3-digit numbers I have to make. So 111 multiplied by 3 factorial divided by 3 numbers. So each one will appear 3 factorial by 3 times. Multiplied by sum of the digits, 2 plus 3 plus 5, again will be equal to 10. So in this case, you are going to get minus 111 into 20. And that should give you the answer. So we will basically have 66660 minus 2220. So what will be our answer in this case? 64440. That's the answer. So just remember this part instead of getting confused and saying that, okay, there are 4 factorial or there are 3 into 2 or 18 numbers that are possible, 18 numbers that are possible, 2 will appear equal number of times. But then you also have to accommodate a 0 in the second part, and then you will start thinking 18 divided by 4 will not work, right? And then you are going to end up in big trouble. So instead of doing that, what you can do is you can just look at this method. All 4-digit numbers, irrespective of whether they start with 0 or not, minus all 3-digit numbers, which will ensure that whatever you had looked at, which started with a 0, all those cases are eliminated. And that will basically help you solve this question nicely. Let's move on to the next question that we are looking at. What is the largest sum of rupees which can never be made using the coins of denominations 5, 7 and 11? Now this is something which is popularly known as the chicken McNugget theorem. Right? We have to find the largest value that is not possible. Now for 2 things, there is a way that exists. But for 3 things, it's best if you can use trial and error. Now till when will you use trial and error? Till the time you reach the lowest denomination. Now what do I mean? Lowest denomination means that when you have 5 consecutive terms that can be created, the 6th term can easily be created by adding another 5 to the first term. So I'll show you how it works. So in this case, 1 you cannot form, 2 you cannot form, 3 you cannot form, 4 you cannot form. You need not even check. 5 you can form, yes. What about 6? Can you form it? Not really. So 6 cannot be formed. Can you form a 7? Yes. Can you form an 8? Not really. Can you form a 9? Not really. Can you form a 10? Yes. Can you form an 11? Yes. Can you form a 12? Yes. Can you form a 13? There is no way you will be able to create a 13. So our streak has been broken. What next? Can you form a 14? 7 plus 7, 14. Can you form a 15? Yes, 5, 5, 5. Can you form a 16? 11 plus 5. Can you form a 17? 5 plus 5 plus 7. Can you form an 18? 11 plus 7. And now we are getting everything clear, right? So in this context, if you are looking at it, 14, 15, 16, 17, 18 can all be formed. Now if I want to form 19, I can already form 14. I will give 5 rupees more and will form 19. If I want to form 20, I can already form 15. I'll give 5 rupees more, I'll form a 20. So as soon as you get a streak of 5 consecutive numbers that are possible, everything else beyond this should be possible. So what is the largest sum of rupees which can never be made? The answer in this case is going to be equal to 13. You can't make 13 Beyond that, everything you will be able to make. Whatever number you feel like, you will be able to create using 5, 7 and 11. So it's a very interesting concept, very important concept that you have. And that is basically the chicken McNugget theorem that exists. Next question, let's look at it. The first 100 positive even numbers, which basically means you are writing 2 into 4 into 6 into 8 into 10 and so on till the time you are reaching 196 into 198 into 200. And all multiples of 10 are erased. So 10, 20, 30, 40 till 200 are erased. What is the units digit? You need not multiply everything. You need not convert everything into 2 into 1 into 2 into 3 into 4. You are not required to do all those things. You are not expected to do 2 raised to 99 or whatever number you are getting. You just have to look at brackets. Now you know that every set of 4 digits that will be there or consecutive even numbers that will be there will be ending in 2468, 2468, 2468. And how many such iterations do we have? For 10, we had one iteration, 22, 33, 44. So 220 iterations we will have, right? It's not 20 multiplied by. This is going to happen 20 times. That is what you have to understand. What is the product of 2, 4, 6, 8? 2 4s are 8, 8 6s are 48, 8 into 8 is 64. So the units place digit of this number is going to be 4. Now I have to figure out 4 multiplied by 4 multiplied by 4 20 times will end in what number or what units place digit. So we can see very easily 4 raised to 1 ends in a 4, 4 square ends in a 6, 4 cube ends in a 4, 4 raised to 4 ends in a 6, and this pattern follows. So whenever 4 is raised to an even power, it ends in a 6. So 4 is raised to an even power, it should end in a 6. And that will basically be the answer. No need to get into complicated question types and complicated stuff that involve 2 raised to 1, 2, 3, 4 and last non-zero digit of n factorial. No need to get into all those things at all. You can simply do it by using iterative approach. Let's look at the next question that we have here. Very, very interesting question. Again, try this out. And if you get confused, then have a look at the solution that we are going to follow. And that will, I think, help you a lot. So 6 men are in a queue at the ticket counter of PVR cinemas. All of them want to buy a ticket which costs rupees 460, some awkward denomination. Each of the 6 men has exactly one currency note. 3 of them have 460 rupee note and the other people have 920 rupee note. There are no currency notes of any kind at the ticket counter initially. So the ticket counter will have to get money first to be able to give change. That basically tells you that the first person has to be a 460. You cannot have someone who has a 920 coming up to the counter because the ticket is of 460 rupees. So if someone comes and pays 920 rupees, there is no way you will be able to give back 460 rupees. That is a problem. So the first person has to be 460. We also know that if you are looking at the last person, this is very critical, you will have 1, 2, 3, 4, 5 and 6 people are there, right? If the last person is 460, then again it's going to be a problem because the counter needs to get 3 460 notes to be able to give back 3 460 notes, which basically means that the last person has to be a 920. If you are able to understand this, you will be able to crack it very quickly. Now, there are 4 blanks that are there, right? Now there are 4 blanks that are there, but you have to understand what can happen here. Now I have 2 920s and 2 460s that are there. Now these 4 notes, right, consist of 2 into 460 denominations and 2 into 920 denominations. So you should be able to arrange them in 4 factorial by 2 factorial, 2 factorial ways, which basically means 24 by 4 or 6 ways. But there is a problem. Again, as I said, I cannot have more 920s before 460s. So what are the cases that are not possible? Now I am left with 2 920s. I can happily have one 920 here and it should not be a problem. But if I have another 920 here, the number of 920s will be greater than the number of 460s if you are counting from left to right, which is going to be a problem. So you cannot have a 920 here, right? Similarly, if you have a 460 here, then you can have a 920. That is not a problem. But you cannot have 2 consecutive 920s appearing here. And that is why, except this case, every other case should be fine. Because if this is 920 worst case, and if this is 460, I can still have a 920 here and it will not be a problem. Right? That's why out of these 6 ways, you cannot have one way, which basically means there are 5 ways to do this. Now I have arranged 460s and 920s among themselves in 5 possible ways. That is something that we have done. But I have 3 people with 460. I don't know who is the first. I don't know who is the next. I don't know who is the last. So they can be arranged among themselves in 3 factorial ways. The people with 920 can be arranged among themselves in 3 factorial ways. And overall, of course, we had 5 ways that we had figured out that 460s and 920s will be arranged among themselves. So we are going to get 6 into 6, that is 36, into 5, that is 180 ways. So the correct answer to this question is going to be 180. Let's look at the last question, the 50th question. It happened very quickly, right? But let's look at the 50th question now. V is a 56-digit number. All the digits except the 32nd digit from the right are the same. If V is divisible by 13, which of the following can never be the units place digit of V? So let's say, for example, you have a 56-digit number, right? Which comprises of a lot of A's and a B. So all the digits except the 32nd digit from the right. So let's say, for example, I have 31 A's that are present. Okay? I have 31 A's that are present. 32nd from the right is B, which basically means I am left with 24 digits and all of them are going to be A's. So 24 digits are going to be A's followed by a B followed by 31 A's. Now you know that if you are dividing something by 13, if it is a collection of 6 same digits, then it will be divisible by 13. Why? Because this is going to be triple A, right? If you are looking at this one, if you have triple A, let's say for example, and triple A, 6 times if it is happening, then what can you say? This is going to be triple A into 1001. And 1001, as you know, is going to be 7 into 11 into 13. So a collection of 6 repeating digits is going to be divisible by 13 for sure. Which basically means a collection of 24 digits should also be divisible by 13. A collection of 30 digits should also be divisible by 13. So what are we left with? BA. Now, if this number is divisible by 13, this part BA should also be divisible by 13. If BA is divisible by 13 and B and A are single digit numbers, what all values can A take? If you look at the product, 13 ones are 13, 13 twos are 26, 13 threes are 39, 13 fours are 52, 13 fives are 65, 13 sixes are 78, 13 sevens are 91. And then you will start getting 2-digit numbers. So I have to have 3, 6, 9, 2, 5, 8, 1. 4 is not possible. 7 is not possible. So which of the following can never be the units place digit of V? The answer is going to be option D, that is 4 and 7. And that basically brings us to the end of this particular video. Do let me know in the comment section if you enjoyed this video, and if you had a better approach or a different approach for any of these questions, please feel free to let me know in the comments section. And in case there is any question that you have regarding any of the methods that I used, again let me know in the comment section and I'll be more than happy to indulge your query and to help you understand the concept in a much more better manner. And if you have liked the video, do not forget to give a like to this particular video. If you think this is useful, do share it with your friends, do share it with everyone that you think is going to benefit from this video. That will help us reach out to a larger audience and make sure that we keep creating content for you in the coming few days as well. So wish you all the best for the test, and I hope you really enjoyed it again. So do not forget to like, share and subscribe to this particular channel.